Okay, so part 2, we find all of our zeros. So when I take the quotient and I set it equal to 0 to find my zeros, I can add 10, divide by 5, I get x squared equals 2, so x equals plus or minus root 2. And then I also remember that x equals negative 1 and x equals 6/5. From here, those I got from my calculator, but answering the question, which is very important, these are all of my zeros. So I have 4 zeros. They all happen to be real, only 2 of them happen to be rational. So, this process is the process we're going to be using a lot now. You're going to use your calculator to help you as much as you can, find as many zeros as you can from the calculator, then do synthetic division, and try to either factor, or you might have to use the quadratic formula, or complete the square to find the remaining zeros. Also, real quick, going back to the calculator, remember I said that I knew this other zero had to be irrational from the calculator? Well, I knew that because, again, it has to be some small number here between 1 and 2. And if I look back at my possible rationals, the only possible rational between 1 and 2 is 6/5. And since the zero that I found was 6/5, it can't, the other zero here can't also be that. That's how I knew it had to be irrational. Okay, so I want you to find all of the zeros of this polynomial. Pause the video, unpause when you're ready to check your work. Okay, so here you should end up with plus or minus 2i and 11/13 as your zeros. So how did you get that? There's 2 ways for this problem. This one factors. If it factors and you see that, try to factor it. That's probably going to be quicker and easier. So I factored this by grouping, set it equal to 0, take out an x squared, take out a 4. I get x squared plus 4 and 13x minus 11 equals 0. Set them each equal to 0 and solve. And that's how I got 11/13 and plus or minus 2i. Now, what if it didn't factor or if you didn't recognize that? Well, you can use your calculator. So if I put this into my calculator, I've already done that conveniently, put that in, graph, I see that I have at least one real zero. Whether it's rational or not, I'm not sure. Pretty good idea of what it should be though. So I do second calculate 0. I'm going to do a left bound of 0. And I'm going to do a right bound of 1. Guess doesn't matter. And I get this. So 0.8461538.5. I don't know if that's rational or not. That's kind of a weird decimal. I don't know what that is. So this is an example of where the possible rationals might help. Again, if I list my possible rationals, which I did not say you had to do, I look at what is a possible fraction that's really close to 1. Well, anything over 1 is not going to be a fraction, so it has to have a denominator of 13. 4/13 is less than a half. 11/13 is really close to 1. 2/13 is less than a half. And 22/13 is more than 1. 44/13 is also more than 1. So the only possible one that's really close to 1 is 11/13. And so if I go to my calculator, and I actually just type in, well, what is 11/13? I don't know. Let's find out. 0.8, oh my god, 0.8461538.462, and so on. So I know that my zero is 11/13, and then I could come down, I could do synthetic division, and use my coefficients, 13, negative 11, 52, negative 44. Do my synthetic division. I get 0, and I can solve 13x squared plus 52, which when I set equal to 0, I get x squared equals negative 4, and x equals plus or minus 2i again. So, again, I had two choices here. I can do either synthetic division or I can factor by grouping, but since I can factor by grouping, that is the easier choice. Either way, my answers are plus or minus 2i and 11/13. Okay, now a little refresher on what we've already done. I want you to determine if 8x plus 6 is a factor of this polynomial, and determine if 5x minus 2 is a factor of this polynomial. So a little practice of division. Pause the video, and do both of those. Unpause when you're ready to check your work. Okay, so after some painstaking long division, hopefully you came to the conclusion that yes, both of these actually are factors of the given polynomials. So 8x plus 6 is a factor of 8x to the fourth minus 50x cubed minus 26x squared plus 4x minus 6. And 5x minus 2 is a factor of 5x to the fifth minus 17x to the fourth minus 9x cubed plus 46x squared minus 46x plus 12. How do I figure that out? I did long division. So here I set up my long division. Here you can see my work. Hopefully it's correct. And I end up with 0 as a remainder. Therefore, it has to be a factor. There's the quotient. That's another factor then. Same with the g of x example. I set up my long division. This was very long, painstakingly long, but I get 0 as a remainder again, so yes. The divisor of 5x minus 2 is a factor, and the quotient of x to the fourth minus 3x cubed minus 3x squared plus 8x minus 6 is also a factor. So, make sure we know the rational zero test. Again, honestly, it's not terribly useful because we have calculators. However, it is easy points, so factors of the constant term over the factors of the leading coefficient, and it can help you with your thought process when you're finding zeros. Does my zero make sense? Is it even possible? So it can help you with things like that. You know, that rational, logical thought process that is actually useful in life. That's where this can come in. To find all the zeros of a polynomial, use the calculator. If it doesn't factor, then use synthetic division with the zeros that you find.